that times t? Well, I'm going to multiply by the reciprocal of 3. The 1/3 is going to be 3. Natural log of 100 divided by natural log of 3 is equal to t. Multiply by the reciprocal of 1/3, 3, and then divide by natural log of 3. Isolate the t by itself. And then in order to work this, you need to do what? Punch it in your calculator. When you punch it in your calculator, you have to put natural log of 100 divided by what? Natural log of 3. Okay? Everybody realize when you punch that in your calculator, you'd have to put 3 natural log of 100 in parentheses divided by natural log of 3 in parentheses. You can't leave off the parentheses around the 100 or you will not get the right answers. All right? Is that okay? And that'll tell you if you change it to a decimal how many days it's going to take or how many weeks it's going to take to have 1,000. And I know you can punch out in a calculator and work. This is how exponential, natural growth, natural decay all work. You're going to work them all the same way as long as we tell you the original amount and one other amount on the way. You're going to work them all the same way. It's just a matter of you being willing to do all of this work. Now, I will tell you this. This is the easiest one of these, and I'm going to teach you 2. And the whole catch is, if you can do this one, you can do all the different types of exponential equations that are in your science book. There's all kinds of formulas that have this E in them in your science book. If you can do this one, you can do any of them. All right, now, with that in mind, here we go. Before I erase it, everybody understands the first thing you got to do is get your A sub 0, and then you got to get your K. Then you write your formula. If you don't have this formula right, it's over. Once you get that, if you want to know how many is there in 6, you just put the 6 in your T. Watch for little things. Now, if you turn this into a decimal, I don't mind, but you got to carry it out to how many places? 4. I just assume you're not turning it into a decimal. It's easier. All right. Well, Mr. Evans was in the lab, and he discovered a chemical reaction, and what happened was it was decaying. The stuff was there, and then it disappeared, or it got so small that he had to have a microscope to see it. The amounts just started dropping. And when he first discovered this new stuff called, you've got to come up with some catchy names to help sell this new product. The love potion. Love potion. I don't like that. That doesn't sound right. Y'all heard the song Love Potion? You know, about, you know. Okay. All right. Don't like that. He discovers this new stuff. And when he discovers it, he realizes that at time 0, there is 800 of them. But 30 minutes later, it's already down to only 650 of them. In 30 minutes, it went from 800 to 650. And what's scaring him about this is he was told in the directions that when he got down to where he only had 100, that he couldn't, he couldn't do anything with them anymore. He needed to at least always have at least 100. And what happens? His population's going down. Now, and we're going to go ahead and do a step there too. We're going to figure out how much does he have after 2 hours, and how long will it be before he's down to just 100. Okay? And since I'm making these up, sometimes the numbers come out to be a little weird. All right, but you're always going to have that information in the word problem. When you look at the word problem, you've got to determine what's the original amount, how much he has after a certain time, and then make a chart of what they're asking. All the word problems can be turned into a chart like that. And it will say something about natural growth or exponential growth, so you'll know which formula we're using. All right. A of t, write it this way this time, is 800 e to the kt. Because I know the original amount is 800. Now, I use this bit of information right here to find k. Helps find k. Okay, see if you can find k. See if you can use that information to help you find k. If you're at home watching at this time, it would be a good idea to try it yourself at home. So I do that for the cameras. Numbers in the blanks, and then solve for k. And just leave the natural log in your answer. Don't even worry about your calculator. You're not going to need it. This is something I enjoy teaching because I know your science teacher is going to show you this. And all of my kids that have me for this class tend to, say, oh, well, I've seen that. Say, when this Comerford gets there. I'm going to write a little bit on the board. And if you're having trouble, you can look at the board. But if you can, try not to. I'll give you a hint here if you're using a calculator. If you find k and you work it out and you get your decimal, it's going to be negative. Because the amounts are doing what? Decreasing. If you're using this formula, anytime your k is positive, you're talking about something that is what? Increasing. Anytime the k is negative, you're talking about something that is what? Decreasing. And it fits in your brain. Notice how logical that is? How that fits in the brain? Oh yeah, my k is positive. It's growth. K is negative. It's decay. How many people were able to get that as their k value? Raise your hand. Anybody want me to chat about it for a minute? Be brave and tell me. All right?
I should go from 6.
Divided by the 800, right? And then I just reduced that. 65 over 50 divided by 5 and 5, and I got 13 over 40. Okay? That's not right, is it?
No, not really.
13 over what?
16.
16. Now I see why y'all kept looking at me. You notice I kept looking at that thing and, Mr. Evans, that's not right. 16. 13 over 16. I bet that looks a lot better. Thank you very much, because Mr. Evans was not, that's on film, of course, that I screwed up. Yeah, it's all right. I'm over 60. Okay. Now, K is equal to 1 over 30, natural log of 13 over 16. Does that work better? Yeah. Okay. So I go over here and I write A sub t, A of t equals 800 e to the 1/30th natural log of 13 over 16 times t. And if I want to know how many I'm going to have in 120 minutes, I'm about to put the 120 in where? Right there. But notice, you've got to write the formula. If you don't have that formula where you can read it, you can't do this. And if I were working it, A of 120 equals 800 E 130 natural log 13 over 16 times t. And how much is the t? The t's what? 120? See if you can work that out and see what you get. I think everybody already knows you need to do what? Take 1 over 30 and multiply it times what? 120, right? Is everybody okay with that? I'll write out a step here. I'm not going to skip a step. Is that cool? Somebody's watching the video and goes, you know, he never asked those questions about higher thinking skills. He just asked them if they know how to do it or not. Yeah, because when you get to college, nobody's even going to do that. They're just going to throw it all on the board. You're just going to be writing. I'm not going to dare look at you and go, do you understand this?
So you do the 130 times the 120?
Yeah. 1 over 30 times 120. Because that always makes that just turn out really pretty. See, that makes the numbers a little bit easier. And then I'm going to E the natural log of 13/16 raised to the 4th. Because I can bring that power back in. And then I have that magical moment. That's how much you're going to have in 2 hours. And if you want to, you can get out your calculator and punch all that in. And some of you would be better if you just went ahead and did what right here? Turn this into a decimal. So a lot of you probably want to just do what right here? Turn it into a decimal. But if you don't want to do it decimals and you want to do it so that you'll be ready for serious physics, don't use a calculator at all. I got it. Now, somebody, I'd kind of like to know what that is. Somebody got their calculator? Tell me how much that is.
About 348.6.
Okay, 348, approximately 348. Okay, so about 348. And if you turn this into a decimal right here, it would be easier to do. Okay? I mean, it's got to be a lot easier to do with a calculator. All right. See what you can do about the one where I want to know how long it takes to get to 100. This is usually the harder one. How long does it take to get to 100? put it right here. 100 equals 800 e to the 1/30th natural log. Can't write it in there, won't fit. 100 equals 800 e to the 1/30th natural log of 13/16 times t. And you probably, how many of you are noticing that how you work this is the same way that you work this one over here? See, you saw them. Okay? You saw them for K or T, it's the same setup. 1/8 equals e to the 1/30th natural log 13/16 times t. Take the natural log of both sides, right? Okay? Okay, if you put natural log of 1/8 here, you're going to get the right answer. Don't complain. You know, natural log of 1/8 is the same thing as natural log of 2 raised to the -3, right? Okay? I know that's about 2.1. I think. It's going to be negative 2.21. I can't come up with it. Can't do it in my head. Don't worry about it. Do natural log of 1/8 or natural log of 2 to the what? -3. They're going to give you the same. And does everybody agree I can bring that -3 to the front? Okay. These little tricks I'm showing you here about rewriting it is for those people that know the natural logs of the prime numbers. And so if they know what the natural log of 2 is, you bring the -3 to the front, you take -3 and multiply it by the natural log of what? 2. And they just memorize all their natural logs of prime numbers out to 4 decimal places. Yes, people do that. Yes, they do that. You remember to catch people when y'all throw them up in the air, right? Check. Okay. Now, if you want, t is going to equal to the natural log of 8, or 1/8, times 30 divided by the natural log of this 13/16 stuff. And you just punch that in your calculator. They're all going to work this way. Now, I'm going to have 3 problems on the canvas. And the 3 problems I'm going to put on canvas